practice problem number 2 about these engineers and market researchers. Since this is one of those constrained optimization problems, you want to think about the marginal product per dollar per price of these people. We've got engineers are 40,000 a year, market researchers are 20,000 a year. We have these tables of their marginal products. And so number 1 says we currently have two engineers, 3 market researchers, $140,000 budget. Determine whether you currently have an optimal mix. Whether we're behaving optimally or not depends on this marginal product. So that's kind of the benefit side of hiring these engineers. But the cost side of the engineers is how much you have to pay them. So what we're thinking about, so I made these columns over here of marginal product per dollar. So marginal product of the engineer divided by the price of the engineer. So I did this 240, I guess I just divided it by 40. I didn't divide it by 40,000. So I've got for my worker number 1, the marginal product of the engineer is 240 divided by their salary of $40,000, or just 40, equals 6 units per $1,000, I guess. For the market researcher, you get 80 units divided by their salary of 20,000. So I get this marginal product per dollar of salary of 4. So I can make an entire table like that. And when I'm looking at this, it's asking about 2 engineers and 3 market researchers. Again, I can look in this column here and say, well, when I had 2 engineers, the marginal product per dollar is 5. The marginal product per dollar of the researchers is only 3. And in the optimum, those 2 things are equal to each other. The ratios, like Emily said, are equal to each other. And they're not here at number 1. So we know we do not have an optimal mix. How should you allocate hiring between engineers and market researchers to maximize the number of new products? And if you just look at the numbers in the table, it might not make a whole lot of sense. And like these things are highlighted. And as I may have mentioned before, when I came up with these practice problems, when I taught the class on campus, and we did kind of a flipped classroom version of it. And so what I did was I just gave them the PowerPoint slide, and I kind of made this Excel sheet on the fly as I was going over it with them in class. So it's not very pretty because I was kind of doing it on the fly. The way to think about it, how should we allocate the hiring? Again, you want to get your best deals first. Let's make a new set here. You want to get your best deals first. So when you don't have anybody, if you don't have anybody, you got to think about, well, do I want the first engineer? Do I want the first researcher? And again, you're going to kind of make these decisions on a stepwise basis. So you go, well, who do I want first? And then who do I want second? And who do I want third? So when I don't have anybody, my choice is between having the first engineer and the first researcher. And again, if I want to get the best deal, I'm trying to get the person who has the highest marginal product per dollar. So when I'm comparing these two, obviously the first engineer has the highest marginal product per dollar. So I would take that person. And I made this set of cells here was kind of thinking about my budget. So I started with 140,000. Oops. 140,000. And I'll just do it I won't put the zeros in there. And I've hired my first engineer, so I got to take 40 off of that. So I've got 100,000 left. So then I go, okay, well, who do I want next? Who do I want to hire next? My choice is to hire the second engineer versus only the first market researcher. Do I want the second engineer now, or do I want the first market researcher? And again, I compare these marginal products per dollar, and it still looks like the second engineer is best. So I picked, because again, their 5 units is greater than the 4 units for the first researcher. So I picked this second engineer. And so I say, well, I had $100 or 100,000, but I'm spending 40,000 on engineer number 2. I'll subtract 40 from that. I have 60,000 left. And I go, okay, well, who do I want now? And actually, I've got a situation where these 2 are equivalent in terms of how good of a deal they are for the company, because they both generate the same marginal product per dollar. So I'm kind of indifferent between these 2. And what is sort of nice about this problem is that I actually have enough of my budget left over to hire both of them, because I could hire this third engineer for 40,000, and I could hire the first researcher for only 20,000. And I would end up spending all of my budget. I end up hiring the best deals at each stage of the process. I end up using it all. If you want to figure out whether it's optimal or not, I mean, because I just kind of showed you the steps you should take, you know, the way you should try to solve these problems is to figure out marginal product per dollar and stuff. And you may wonder, well, okay, I can kind of make sense of how that procedure works, how that process works. I look at these columns and I figure out the best deals and I do that. But am I guaranteed that this is the best way to hire these people? Am I getting the best output? So the way that we did it before, when we had 2 engineers and 3 researchers, let's see, that would have been, did we spend all our budget that way? 2 engineers times 40 plus 3 researchers. So if I hire 2 engineers at 40,000 plus 3 researchers at 20,000, then that does spend my whole budget. I'm using up my whole budget for this. But if I think about how much output I'm producing, so with my 2 engineers, I'll add up their output. So an engineer number 1 adds 240 units of output. Engineer number 2 adds 200 units of output. Researcher number 1 adds 80. Researcher number 2 adds 70, etc. So I can add all of these marginal products up to figure out how much output is being produced. And when I do that, my 2 engineer, 3 researcher combination generates 650 units of output. And I spend $140,000 on their salaries. But I kind of tried to convince myself that hiring 3 engineers and 1 researcher would be better. I know I'm spending my budget, just like I did before, but if I think about how much output I'm doing now, I've got these 3 engineers and 1 researcher. And so if I add up all of their output, I get 680 units. So I do get, again, I've spent the same amount of money on my budget, but I do get higher output than I had in the combination in question number 1. So it seems like allocating the hiring between engineers and market researchers in the way that I did generates a higher amount of output for the same salary, same total salary. And then for number 3, when your budget has increased to 240, that must have been how I had it here before. If the budget is 240 now, then up here where I had my formula of 140,000, well, now my budget is 240. And you could just go through, now when I've got this 3 engineer, 1 researcher combination, now I've got $100,000 left over. And so I could keep going. And so you could try that on your own if you'd like. And you should end up seeing that the output that you get at the end of that should be probably about 960-ish. So I'll leave that for you all to try to solve if you have 240,000 instead of only 140,000.